the fact that both of you are engaged in thinking about the future is very encouraging, and you've certainly helped us with our inquiries. So Dr. Christensen and Mr. Clegg, thank you very much indeed for your evidence. We're now going to Thank you very much. We're now going to our final panel of witnesses, and we're going to switch our attention from the seas to the air, and we're going to look at aviation. And I'm very pleased to introduce and welcome our next two witnesses, the final two witnesses, and they are Glenn Llewellyn, who is the Vice President for Zero Emission Aircraft at Airbus, and Dr. Brian Yukto, who is the Chief Engineer for Sustainability and Future Mobility at Boeing, and he's joining us from the USA, where it's quite early in the morning, so thank you for joining us this morning. And I'm going to start by going to my colleague, Carol Monaghan.
Thank you, Chair. And the first question is really for both of our witnesses. So what role do you see for hydrogen or hydrogen-based fuels such as ammonia in decarbonising aviation?
Sure. So perhaps I can start. I think maybe just to set the scene a little bit, already our aircraft are certified to carry what's called sustainable aviation fuels on board. Unfortunately, the amount of sustainable aviation fuel which is being used across the globe really is still at a very small level, much below the aircraft's capability. We need that to scale. We need the usage of sustainable aviation fuel to scale, and that definitely needs to happen in the 2020 to 2030 timeframe. And then specifically on hydrogen, so one of the sustainable aviation fuel types is called biofuel. The other sustainable aviation fuel type that we're interested in the short term, in the 2020s, is called synthetic fuel or power-to-liquid synthetic fuel, which has hydrogen as its major ingredient. And we see synthetic fuel as being extremely scalable, much more scalable potentially than biofuel, in terms of land use, in terms of water use, in terms of cost also. It has much more potential to come down than biofuel. So hydrogen already, in the context of existing aircraft, in the context of future long-range aircraft, in synthetic fuels is going to be really, really important. And I think compared to many industries, aviation doesn't have so many choices. Then the other way to use hydrogen on aircraft is in its raw form. So using hydrogen in its raw state on board the aircraft is something which we are pushing extremely hard. There are definitely challenges, there are definitely questions which remain to be answered in our drive towards that pathway. We see it nonetheless as extremely high potential. It has, from all of the options we've studied, and we've looked at battery electric, we've looked at all the different sustainable aviation fuels, we've looked at butane, propane, methane, ammonia, the list goes on. And hydrogen looks like it has the potential to have the lowest climate impact compared to all of the other options. And on top of that, it has the potential to have really one of the best costs compared to all of the other options. So it's a challenge. It's one where we have to develop technology for. It's one where there's an ecosystem that needs significant change for. But let's say the carrot or the prize at the end is significant, and that's why we're pushing so hard in that direction.
Thank you. And if I could ask the same question to Brian, what role do you see for hydrogen in aviation for yourselves?
Thanks, Ms. Monaghan. We are organized around a four-part pillar that I'd like to describe and sort of put hydrogen in context for our decarbonization strategy. The first element of our pillar is fleet renewal and generational efficiency improvements. Second is network and operational optimization. Third is sustainable aviation fuels. And fourth are advanced technologies like hydrogen. So just briefly on each of those. On fleet renewal and generational efficiency improvements, new airplanes provide significant efficiency gains. Each generation of aircraft reduces fuel use by about 15 to 25%. So fully deploying the latest generation of aircraft is the most significant contribution to emissions avoidance and reduction available to us over the next decade.
Sorry, can I just ask you then, how quickly would you renew the fleet?
So right now, the latest generation of aircraft, as an example, between both Boeing and Airbus, are a minority of the fleet within their classification or within those market segments. And so there's a significant opportunity over the coming decade to introduce those new aircraft into the fleet.
Okay. Thank you.
Just briefly on the second, briefly on efficiency for a second. So those efficiency gains are important, and those efficiency gains will continue. They'll absolutely continue. But we know that efficiency doesn't necessarily get us all the way towards net zero. And so the other elements of our strategy come into play. So briefly on network and operational optimization, we assess that flying aircraft more efficiently in the airspace can reduce emissions by about 12%. These include introducing procedures such as continuous descent approaches, equipment upgrades, GPS, et cetera. We are demonstrating those right now on a program that we call EcoDemonstration, which is a large-scale aircraft that flies and matures these technologies. The third element of our strategy is sustainable aviation fuels. So given the near-term needs for emission reductions, as Mr. Llewellyn pointed out, and that the primary sources of aviation emissions are longer haul flights, sustainable aviation fuels offers the most immediate and far and away the largest potential to reduce carbon emissions over the next 20 to 30 years in all aviation segments. So we have flown 100% SAF on our aircraft in 2018. We've recently committed to making all our aircraft 100% SAF capable by 2030, removing any technical barrier to—
Sorry, I'm missing that 100%.
Sustainable aviation fuels.
Okay, thank you, thank you.
So right now, just as an example, the aircraft are generally certified to use blends of sustainable aviation fuels that are up to about 50%. So getting to 100% sustainable aviation fuels on regular flights has some technical barriers. We have committed to eliminating those technical barriers by 2030, thus removing any aircraft level barrier to deploying sustainable aviation fuels at scale. And now we're turning our attention to actually scaling their use in aviation. And then to the question and the last point, the fourth pillar of our strategy is advanced technology and alternative propulsion systems, electric, hydrogen, et cetera. So we have flown a number of electric aircraft. We have established a joint venture which will certify an electric autonomous airplane. That joint venture is called WISC. That's a small aircraft that carries roughly 2 people and it's fully battery powered. On hydrogen, we have a long experience with hydrogen. In 2008, we flew a fuel cell based aircraft. In 2012, we flew a liquid hydrogen and combustion based aircraft. In 2012, we also flew a fuel cell on board one of our large-scale 7 series aircraft. And likewise, we have some significant technology development in our space systems, which are related. A few weeks ago, we as part of the SLS program, had demonstrated a system that has effectively 1 million kilograms of LH2 and millions of pounds of thrust. And so those relevant technologies we are exploring. We have flown in the past, and like Mr. Llewellyn, we could talk about this sort of opportunities and challenges there.
Thank you. That was really comprehensive. If Glenn, if I could come back to you again and just ask, I understand that Airbus has recently halted its research into electric aeroplanes. Do you have reasons to believe that hydrogen will be different?
Yes, so to be precise about what we've paused is the activity looking at battery-powered aircraft for large commercial aircraft applications. So the project probably you might think about is a project called EFAN-X, where we were looking at using batteries in a hybrid electric system on board an aircraft. And really what we saw is that batteries are just not progressing at the speed that we need in order to achieve, I think, the ambitions which we've set ourselves, but also we see in terms of expectation from society and regulators. So battery technology is just not moving fast enough for commercial aviation applications. We've seen in various discussions earlier today that many industries have the option for perhaps short-range missions, smaller aircraft, smaller applications for very small aircraft, for very short-range applications. Batteries are still perhaps interesting, but when we talk about commercial aviation, which is really where the bulk of the climate impact is, then batteries are not an option. And to put it into context a little bit, the best certified lithium-ion batteries we could imagine in the coming years are about 150 watt-hours per kilogram. So that's the amount of energy per kilogram. Hydrogen has about 33,000 watt-hours per kilogram. Kerosene has 12,000 watt-hours per kilogram. So hydrogen has more energy per kilogram than even kerosene. Now it has a challenge in terms of volume, which we can talk about, but battery technology would need to go very, very far to compete with hydrogen for large aircraft applications, and that's the bulk of the climate impact. That's what we want to address. So that's why we're pushing so hard in our exploration of hydrogen.
Thank you. We've heard some evidence that it's limited at the moment, that water vapor emissions can actually contribute to global warming as well, because they can capture particulate matters. Do we need to be looking at this more carefully?
Yeah,
and that's
for sure.
Either of you who's able to answer.
Yeah, for sure we do. I think the climate science around aviation and emissions at altitude has progressed quite a lot over the last decade, but our understanding and the level of uncertainties is still at the level where we need to progress further. We have plans to flight test various different types of energy, so including kerosene, Jet A1, different sustainable aviation fuels, hydrogen, and we want to be able to analyze what is in the jet stream behind these aircraft, and we want to provide that data to climate scientists so that we can come up with scientifically relevant solutions. We're already engaged with climate scientists, and that's why we have quite a lot of confidence that hydrogen is so promising, that even when you take into account the water vapor, there is no particulate matter and therefore no ice accretion and therefore much less radiative forcing. So we see lots of things going in the right direction, but we want to absolutely confirm all of that as part of our decision-making process over the next few years.
And some of these fuels you've mentioned, how dependent are they on direct air carbon capture and other technologies?
Yeah, so synthetic fuel is very dependent on direct air carbon capture if we want it to be carbon neutral. You can use carbon from point source, so off an industrial chimney, but then you wouldn't be net zero. So you need direct air carbon capture in order to be net zero. And therefore, we see it as an extremely important technology for aviation. If we could put that kind of technology on the engine at the back of the aircraft, we would probably do that, but we don't have that luxury. We just couldn't fly if we did that. That engine is more or less our chimney, let's say. So we see it as a really good option for keeping that technology on the ground and extracting CO2 out of the air. And in the first stage, perhaps sequestering the CO2, bringing the cost down while we scale the sequestration. And in a second step, using that carbon for the creation of synthetic fuels. And I think we're going to have to take that sort of approach to get the cost down to the right level for this to scale massively.
Thank you. And Dr. Yukto, do you have any comments on these points?
I agree with Mr. Llewellyn on those points. And on the non-CO2 question related to contrails, both, I do think this is an area for further study. Both hydrogen and sustainable aviation fuels have potential for contrails. We know that 100% sustainable aviation fuels will have less contrail formation and persistence than jet fuel. There isn't yet a strong body of research to compare hydrogen and sustainable aviation fuels. So I think this is a target of opportunity.
Thank you. And my final question is about biofuels, because we've heard we've been given some evidence that would suggest that biofuels may lead to non-sustainable land use, or if they're adopted in a widespread manner, that there could be insufficient supplies. So I don't know if either of you have any comments to make about biofuels in aviation.
Maybe I could start. There are various feedstock pathways under consideration. We think that they need to be appropriate for the region and appropriate for the regional norms and economy in which they're produced. We have initially focused our attention on waste-based feedstocks, such as municipal solid waste, which have no land use impacts. As it relates to those pathways that may involve crop-based feedstocks, we believe in strong sustainability standards and third-party accreditation on that front. We're not prescribing a fuel that would ultimately have land use change, but instead, working with various feedstocks, pathways, partners that have both economic potential and the potential to meet third-party accreditation.
Thank you. That's really useful. And Glenn, do you have any further comments on that?
Yeah, definitely. We absolutely have to be careful about the feedstocks we use and make sure that we have properly accredited sustainable aviation fuel. There could be challenges as biofuel scales in terms of availability of feedstock, and definitely using waste is for sure the right way for us to go, especially as this moves forward. I think this potential limitation is why synthetic fuel is so interesting, and synthetic fuel is hydrogen has hydrogen as a main ingredient, and why hydrogen just in its raw form can be extremely interesting over the long term. I think what we're advocating here is really an and strategy. Several people have said it. For other industries, there's no silver bullet. We're going to need to put maximum effort into each pathway. Hydrogen certainly looks really promising for multiple applications. Synthetic fuel in the shorter term, hydrogen aircraft in the medium term. Biofuel, it's there now. Let's use it, assuming that the feedstock is correct, and let's go full speed on all pathways.
Thank you. That's really useful, and it's a message we've heard several times this morning, as you say. So thank you both very much. Thanks, Chair.
Very much, Carol. We'll now go to Zara Sultana.
Thank you, Chair. My first question is to Glenn. How dependent is Airbus's research into hydrogen planes dependent on the wider uptake of hydrogen in other sectors? Yeah,
good question. It is dependent on hydrogen uptake in other sectors. We need a massive scale up of renewable energy in order for, let's say, global society to meet the Paris Agreement. From what we see many industries needing hydrogen in order to meet the objective set out in the Paris Agreement. And we see the cost of renewable energy coming down. Electricity is a very important driver in hydrogen cost. We see those costs coming down. We see many more end users of hydrogen starting to put their plans in place. And that is definitely going to be needed to scale hydrogen infrastructure, to scale renewable infrastructure. Fossil fuel today is around every corner. that needs to be replaced by something. Our view is that hydrogen, it may not be around every corner in the future, but it'll certainly be around every second corner because it's such a good energy carrier for renewables. And we want to position aviation to benefit from this future ecosystem, which we believe is going to be there.
And should there not be a wider uptake in other sectors due to costs and lack of infrastructure or government funding, how would Airbus intend to achieve net zero aviation?
I think it'll be extremely difficult, and I think it'll be extremely difficult for global society to meet the Paris Agreement if we end up in that place.
And would you support a sustainable aviation fuel mandate, which some European countries and in the EU they're talking about?
So we definitely support incentives to increase the use of sustainable aviation fuels and eventually zero emission aircraft. The timing, the way that this is implemented needs to be done extremely carefully. What can happen is what's called carbon leakage, where people refuel where there's no mandate and then use their aircraft in the locations where there are mandates. Aviation is an international game. And so what we're really advocating for is that, places of big influence, the UK has huge global influence, European Union, US, let's if we can have these big players using their global influence to get global measures in place where there's a level playing field and we don't see silly things like carbon leakage happening, I think that's going to be the most productive.
And Dr. Brian Yukto, do you have any points to make on that?
Ms. Sultana, to your first question about the broader hydrogen economy, I think the answer is it's a prerequisite in order to really see economical use in the aviation industry. If such use were technically possible and certifiable ultimately in a product. The reason is that aviation on the scale of fuel usage in the transportation and broader economy is a relatively small user and may not by itself be able to drive the economics of hydrogen to a place where it would be economically viable within the sector. So I do think that if such aircraft were technically viable and certifiable, that ultimately for them to be economical would need a broader hydrogen economy as a prerequisite. With respect to sustainable aviation fuels, I think the UK government has been supportive and is a leader on supporting SAF development. We certainly welcome government involvement in this market because ultimately, we've committed to removing the technical barriers to use, wide-scale use on current and future aircraft. And what remains is catalyzing ultimately the use in the market and the scale economics from deploying widely. And so, I think we certainly support enabling positive incentives, incentive mechanisms, and working with producers and users to catalyze the sustainable aviation fuels use in the aviation sector.
Thank you. Both panelists have mentioned the role the UK plays internationally. What can the UK do nationally in the UK to accelerate the decarbonisation of the aviation sector? And I also want to ask about the opportunity COP26 presents to show leadership in this area. So what more can the UK government be doing, essentially? So I'll start with Glenn on that.
Sure. I think there are perhaps several streams. Definitely massive increase in the amount of renewable energy that's available, the amount of sustainable aviation fuels that are available. So this is really something to be done in the energy value chain. I think whatever can be done there to increase the scale, aviation is going to be a part of the future new energies ecosystem, and we can benefit from that if it scales sufficiently. On the technology side, I think if we're clever about how we do this, and if I take hydrogen technology as an example, we are taking hydrogen technology from the energy sector and the automotive sector primarily, liquid hydrogen tanks, fuel cell technology, liquid hydrogen distribution. We have hybrid systems that we're looking at, electric motors. We may have a small amount of battery. A lot of these are coming from these other industries. If we're clever about how we do this and how we invest, we're going to increase the performance levels of these technologies because we're obliged to in order to make them commercially viable for aviation applications. That technology should then find itself in a subsequent phase back in the energy sector, back in the automotive or ground transportation sector. And I think the various nations and regions can do something quite powerful there by recognizing this circular effect and using aviation as a platform to get this higher performing technology, which will then benefit society more at large. And I think, you know, we've been hearing just very recently that in fact, even for 2021, the ATI research budget for aviation is being challenged, is going to be reduced compared to what we expected. We're an international company. We need to be thinking about how we keep some of these topics alive, how we keep them going at the pace that we need. And so, you know, we're a little bit perturbed by this, to be quite frank, and now trying to figure out, okay, where are we going to do this research and how are we going to progress at the pace we need? You know, we've been talking about, with the challenges that we face, we've been talking about needing a sort of doubling of the ATI budget. And in fact, what we are seeing is reductions compared to what we had set as previous expectations. So I think there's a massive circular benefit, and I think there's a massive benefit in the UK in terms of these new energy technologies, which I think we've got an opportunity to work together on. But you know, we need to fix in the short term some of the challenges that we're facing.
Just before I go to Dr. Bryan on that, there have been recent announcements, for example, from the South Korean government investing in hydrogen technology. What examples do you have of leading countries, as you're an international company, other countries doing on hydrogen research and technology? And is there anything that the UK can learn from that, other than the points that you've already made?
Sure. I think in Asia, there are various players who are benefiting from government support and increasing, in fact, government support in the current times on the types of technology that we're interested in. We've seen a huge shift in the US with much more investment in the kinds of technologies that we're interested in. We already, I think, in 2020 started seeing a very strong position emerging in terms of hydrogen strategy and hydrogen technologies, electrical technologies in France, Germany, and a little bit laterally in Spain. So there are definitely benchmarks. There are definitely places that are doing this at a very ambitious level. And you know, we think the UK has an amazing powerhouse of technology capability that we would like to benefit from. But this is about technology and economics, and we've got to make sure that the two fit in order for us to take it to the market ultimately.
Thank you.
Thank you very much indeed. Sorry, Dr. Yukto.
No, I was just wondering if Dr.
Yes, you're absolutely right.
Yeah, just briefly, you know, we think that this is a team sport, that net zero is a team sport. I think the 10-point plan is absolutely a great model. Just briefly on what we've done and how I think we can work together. You know, certainly we will continue to invest in advanced technologies, research and development to improve efficiency and ultimately decarbonize. You know, just on a sense of scale, we've invested over the past decade and a half, $60 billion into this topic. but it would be impossible for either industry or governments to navigate this challenge alone. And so we welcome initiatives like the Jet Zero Council as a significant step in the right direction. That's a forum to work jointly with aviation and aerospace industries on the technologies and policies and regulatory frameworks. And so I think, Jet Zero is a great model. Boeing is willing to be an enthusiastic participant in the UK Jet Zero Council. And I think that it would be great and powerful to have both global aviation manufacturing leaders represented on that council. I echo Mr. Llewellyn's comments with respect to ATI. We've recently done an accelerator with ATI. I think that the work that ATI does is important, and I think that additional focus there is welcome. And maybe Ms. Sultana, to your last question about what else the UK can do to prioritize, I do think that sustainable aviation fuels offer the most immediate and largest potential to reduce carbon emissions over the next 20 to 30 years in all aviation segments. So initiatives like the Jet Zero Council or other initiatives that focus on this topic and can help enable and catalyze scale in that domain can significantly help to reduce aviation's impact on the environment.
Thank you.
Thank you very much indeed, Zara. Just a few final follow-up questions from me. Perhaps starting with Dr. Yukto. In talking about hydrogen, which is the subject of our inquiry, as you know, you mentioned a fuel cell experiment, a prototype in 2008. And in 2012, you mentioned that I think you deployed hydrogen in an experimental basis on the kind of 7 series. That's 10 years ago. That's a decade ago. Give me an example of kind of up-to-date testing, or has there not been, and this is not a kind of point of criticism, has there been a kind of a sluggishness over the last decade on the development and use of the experimental use of hydrogen?
Yeah, thanks for the question. The focus right now is on understanding hydrogen's potential use as part of commercial aviation. And there are a few challenges associated with that. So those technology demonstrators that I mentioned, both fuel cell based and combustion based, represent some important technology developments for how we would ultimately use those systems in aircraft. There are a few challenges. So hydrogen needs to be both stored and then used on the aircraft in a hydrogen system. It can be stored as a gas or it can be stored as a liquid. Storing hydrogen as a gas involves essentially very high pressure composite tanks. Ultimately, when you take the very high energy density that Mr. Llewellyn mentioned in the beginning of his comments, and you put that into a container, let's say a gaseous container, and then you wrap the systems around that ultimately to make it safe to be in an airplane, the energy density of that total system goes down precipitously. So if you think about a scale of megajoules per kilogram, with lithium batteries being roughly 1 megajoule per kilogram, roughly, just to give rough numbers, the way to think about a gaseous hydrogen system at the storage level is it's about 7 times better than lithium batteries. Now, when you put that in the aircraft, that can ultimately lead to an aircraft that from a gaseous H2 storage system can perform about 2 or 3 times further range than, let's say, an all-electric battery-powered system. So gaseous H2 storage is a bit like a competitor to a battery-powered airplane, which are severely limited in range and capability. So that sort of moves you to a liquid hydrogen storage system on board the aircraft. Of course, that imposes challenges related to cryogenic storage. Certainly, the energy density of that total system can now be much higher than the gaseous storage system. That liquid hydrogen system comes with other auxiliary concerns related to insulation, related to distribution, and so on. And so that's the way, ultimately, liquid storage on board the aircraft, ultimately the way to increase the energy density of the hydrogen on the airplane. Now, that can either be used in fuel cells or in combustion. And so ultimately, what we are doing is assessing the ability of those systems to be used at various scales of aircraft, and then ultimately be certifiable at various scales of aircraft due to some of the inherent technical challenges that introduces.
And clearly, vehicles in the air, as it were, present more particular challenges than vehicles that are running on the ground or on the sea. But we've heard, both in the road sector, in rail, and in shipping, actually practical applications being deployed now, and perhaps it has been a bit disappointing that the initial work of 10 years ago hasn't led to something that is more close to viability. But is there a danger in which the aviation industry is going to be the one left behind when it comes to either hydrogen or battery technology? And I know that before you were at Boeing, you were at NASA. You worked on the space shuttle. In terms of overcoming what seem to be very difficult challenges, surely the aviation sector should be in the vanguard of this, rather than being seen to be bogged down in problems.
There are inherent physics differences between the various modes of transport. And so the physics challenges in the aviation sector and the need for extremely high levels of safety, of system safety, impose some fairly significant technical challenges to actually using, ultimately certifying hydrogen aircraft. As an example, the fuel on board the airplanes that you fly on today is inerted with an inert gas. And that ensures that fuel vapor doesn't, build up in the tanks and then ultimately lead to a problem with electrical systems. When we introduce, because of the storage challenges that I talked about in my past answer, needing to go from gaseous storage to liquid hydrogen storage on board the aircraft to get to any meaningful scale of passenger transport, that fuel still needs to be inerted. And unfortunately, because of the physics involved in liquid hydrogen, there are very few gases that can inert that system, helium being the only one. And so there's significant invention that's required in order to ensure the safety of the fuel systems on board to ultimately certify the aircraft.
As a final observation, we've been talking about research and development programs. And it is the case, one of the striking features of the industry in which you're both in is that between Boeing and Airbus, you have a 91% market share. There are many more countries than there are aerospace companies of scale. So the idea that the research and development should be nationally led when we have two massive global companies, isn't it rather paradoxical to have it done by nations? Don't we have the opportunity that the two companies should lead the research and development on this basis in order to achieve the breakthroughs themselves, rather than turn to national governments to assist? I'll come back to Dr. Yukto, but perhaps briefly, Mr. Llewellyn.
I think it comes back, at least in part, to a point I tried to express earlier. I think we have a circular benefit to society by taking technologies which exist in the energy sector and in the ground transportation sector on hydrogen. So, hydrogen is not new. It's something that's been handled and used for decades, and technology has progressed in the last 10 years. Now what we're going to do is take that technology and improve it even more for aviation applications. And it's of societal benefit if that technology can then find its way back into the ground transportation and energy sector to assist in the subsequent phases of decarbonisation or getting to climate neutral. So I think there is a societal play here if we do things correctly. And I think we have locations across the world that are willing to benefit from this sort of play, from this interaction, from this dynamic. Where there are countries that are not interested in this dynamic, it's more difficult for us to make the investment because we have two key parameters that we look at. One is technology and two is economics. And when those conditions combined are correct, we choose to invest. And that's I think very normal as an approach. And yeah, the countries who see a circular effect of the technology, I think, will be the countries who position themselves best for a future world which is decarbonized. Sorry, we didn't hear what you just said.
Sorry, Chair, I think we lost your audio.
Oh, I see. We're just turning to you, Dr. Yukto.
Oh, thank you. So I would say, we certainly are not waiting. So we are continuing to evaluate the use of these technologies in eventual products as part of our four-part strategy. So we believe that there's no panacea in this market space. We will continue to execute that four-part strategy, and we welcome collaborating with partners and governments around the world on this mission. As I mentioned, we think that this is a team sport. We welcome being part of initiatives led by the UK, such as the Jet Zero Council. In fact, we even collaborate with our friends at Airbus on pre-competitive, important common problems related to flying aircraft in common airspace and so on. Aviation is extremely international. It's extremely cooperative in ways, but we're also not waiting to advance technologies. We do that as part of our R&D portfolio, and we'll continue to do that.
Thank you very much indeed for your evidence today, Mr. Llewellyn and Dr. Yukto. Especially grateful to you for joining us from the United States today. That concludes this session of evidence of the committee. I'm grateful to all of our witnesses for giving us a very thorough and expert and informed analysis of the various challenges for the use of hydrogen in transportation. We will continue our inquiry in a couple of weeks' time, but for now, order.
The proceeding has ended.